In this lesson, we are going to learn how to use trigonometry to solve two-dimensional problems. Here is the first problem. The angle of depression from the top of a building to a person B at street level is 20 degrees. From another person A, also standing at street level, the angle of elevation to the top of the building is 37 degrees. Please note, the angle of depression is always measured from the horizontal downwards, and an angle of elevation is always measured from the horizontal upwards. Part A of the question is to find x, the angle of elevation from B to C. To answer this question, you need to realize that we have the following pair of parallel lines in the picture. This means we do not have to use trigonometry to answer the question. We can simply use grade 8 geometry. We can therefore immediately write that x is equal to 20 degrees, and the reason is equal alternate angles. In part B, we are asked to find y, the distance from A to C. In other words, the distance from the person at A to the top of the building. To answer this question, we will definitely need to use trigonometry. Step 1 is to identify the following right-angled triangle. The side opposite the 37-degree angle is the opposite side. And y, the side we are looking for, is the hypotenuse. This means we will need to use sine, which is the ratio opposite over hypotenuse. We can therefore write that sine 37 degrees equals 40 over y. Next, we need to make y the subject of the formula. First, we need to multiply both sides by y to get y on the left-hand side. And then we need to divide both sides by sine 37 degrees to get y on its own on the left-hand side. We are now ready to use the calculator. Correct to one decimal place, y is equal to 66,5 meters. Let's tackle part C. Here we are asked to find z, the distance between the two people in the street. Again, we will need to use trigonometry to answer the question. Z belongs to this triangle, so this is the triangle we need to work in. The only information we have is this 20-degree angle and the length of the opposite side, which is what we have just calculated. It would really help if we could find the size of this angle that lies opposite side Z. Can you see a way of finding this angle? The 37-degree angle at A is an exterior angle of triangle ABC. This means you will again need to recall some grade 8 geometry. In other words, angle ACB, the angle opposite side Z, is equal to 37 minus 20, or 17 degrees. We now have enough information to use the sine rule to find z. Please note that I write z on top on the left-hand side, because this is what we want to find. Next, we multiply both sides by sine 17 degrees to get z on its own on the left-hand side. We are now ready to use the calculator. Correct to one decimal place, z is equal to 56,8 meters. Please pause the lesson and check that you agree with my working. Let's do another example together. A farm in the shape of a regular pentagon is given. If the distance from the center to one of the vertices is 3 kilometers, determine the area of the farm. Because this question involves area, we will need to use the area rule. For this, we will need a triangle in which we know the lengths of two sides as well as the side of an included angle. And because this is a regular pentagon, we know that we have 5 congruent isosceles triangles, with two sides equal to 3 kilometers. The 5 angles at the center are also all equal in size. To find the size of one of these angles, we therefore need to divide 360 degrees by 5. This means that each angle at the center is equal to 72 degrees. We can now use the area rule to find the area of one of these triangles. And because the farm is made up of 5 identical triangles, We can just multiply by 5 to get the total area of the farm. We are now ready to use the calculator. Correct to one decimal place. The area of the farm is 21,4 square kilometers. Please pause the lesson and check that you agree with my working. The next problem involves bearings. Two planes take off from an airport at A. One flies on a bearing 63 degrees east of north to B, and the other on a bearing 18 degrees south of east to C. What is the shortest distance from B to C if the first plane flies for 1,250 kilometers and the other for 980 kilometers? We clearly need to work with triangle ABC and are given the lengths of two sides. If we can find the size of this included angle, we can then use the cosine rule to find BC. By now you should know that the angle between north and east is 90 degrees, which means that this part of the included angle will be 90 minus 63, or 27 degrees. The included angle that we are looking for is therefore 27 plus 18, or 45 degrees. We are now ready to use the cosine rule to find BC. We can therefore write that BC squared is equal to the following. And because we want BC, not BC squared, we need to square root both sides. We are now ready to use the calculator. Correct to the nearest whole number. The shortest distance from B to C is 889 kilometers. Please pause the lesson to check whether you get the same answer. Let's do a last problem together. A flagpole has two cables attached to it. One is anchored at C, and the other 7,5 meters away at D. The flagpole is 13 meters high, and the obtuse angle at C is 115 degrees as shown in the sketch. Part A of the question is to find x, the length of the cable anchored at C. To find this length, we will definitely have to use trigonometry. X is the side that belongs to this right-angled triangle. In order to use trigonometry to find x, we will first need to find an angle. The angle at C is easy to find. Can you see how? Because BD is a straight line, we can simply subtract 115 degrees from 180 degrees to get this angle. We are now ready to use trigonometry. We know the length of the opposite side, and the hypotenuse is what we are asked to find. This means we need to use sine to find x. We can therefore write that sine 65 degrees is equal to 13 over x. Next we need to get x on its own on one side. First we multiply both sides by x to get x on the left-hand side. And then we divide both sides by sine 65 degrees to get x on its own on the left-hand side. We are now ready to use the calculator. Correct to one decimal place, x is equal to 14,3 meters. In part B, we are asked to find y, the length of the cable anchored at D. This is the triangle we need to use in order to find y. And we are lucky because we know the lengths of two sides and the size of the included angle. In other words, we can use the cosine rule to find y. We can therefore write that y squared is equal to the following. And because we want y and not y squared, we need to square root both sides. We are now ready to use the calculator. Correct to one decimal place, y is equal to 18,7 meters. Let's go on to do part C. In part C, we are asked to find z, the angle between the two cables. We will again need to use this triangle. Lucky for us, we know this obtuse angle and the length of the side opposite it. And we know the length of the side opposite z. This means we can apply the sine rule as follows. Next we need to get sine z on its own on one side. Correct to one decimal place, angle z is equal to 21,3 degrees. This is the only angle that will work in this triangle. I hope you are now ready for the test. Good luck.